तो hello everyone and welcome to today's session. And in today's session, we are going to talk about Docker, all the functionality of Docker. Okay, what we have not talked yesterday. Let me remove the banner and let's start today's session. Okay, hi everyone. Hi, hello everyone. Okay, so today we are going to talk about Docker storage, Docker networking, and few concept of Kubernetes and Docker Swarm. So I hope you all are doing great. And before wasting any time, let's start with this session. So, चलिए शुरू करते हैं. Okay. So Kshitij, are you presenting your screen? Okay. So let's start.
I am presenting the screen. Actually, I forgot that my mic was off. So let me just share my screen. Sir, is it the your mic is mute?
Oh, sorry. So in this session, we are going to talk about Docker networking and Docker storage. Yesterday, we have talked about what is Docker images, how we are going to build our own image. We have write a Docker file yesterday. Today, we are going to know more concept of Docker file, more concept of how we can push our Docker file to our Docker hub or our Docker registry. So let's continue with this topic.
And now let's start with the topic of Docker networking. So networking is an important concept when it comes to Docker because only there is a concept of networking. So what is actually the concept of networking? Considering this is our host system where we are running the Docker, and there are multiple Docker containers that are being run on the top of the host containers. So networking specifies which container will be able to talk to whom, and like what will be the contain, how will the containers be able to connect to each other, how will they be able to connect to the host or to any other thing. So this is all specified by Docker networks. So like now let us consider the physical host where Docker is installed. So Docker in the beginning create a bridge network layer by default, and it is a combination. Like there is a bridge layer which is created by default. So like what is actually the bridge layer? So bridge layer is the combination of multiple things. Like bridge is the combination of DHCP, and it is the combination of DNS and plus a router. So these are the things that is present in a bridge network device. Other than bridge, there are two other networks that are present by default in the Docker containers. So let us see them, and let us get to know how we can access the Docker networks and how to see which of the Docker networks are present in the system. So let us have a look at that as well. So okay, so now it is connected to the server. Let me zoom in a bit. Okay, I zoomed it. So to see the Docker networks that are present on our system, we just use the command Docker network and ls. So by default, three networks are present, like bridge, host, and none. So what are these three networks that are present by default in our system? So we will have a look at that here. So let us start like bridge. I have already told you it is a combination of DHCP, DNS, and router. And the host, what is host and what is none? So let us have a look at that as well. So like okay, so there are three networks. Like one was bridge, another one was host, and another one was none. So when it come to bridge, so what bridge will do? Bridge will just create right, like it has a router, so it will just route the traffic. All the computers in this network can connect to any network outside as well. So bridge will help us in that thing. Host will just connect like this is the host device and this is the Docker container. So only a connection between these two will be established, and none of the other device or container will be able to connect to the Docker container. And in none, not even the host will be able to connect to the Docker container, and the Docker container will be completely isolated, and it will not be accessible from any outside world. So these are the three networks that are being provided by Docker by default. So namely the bridge, the host, and the null. So like continuing further, like how are the containers able to connect to the internet? Let us have a look at that as well. The containers cannot directly connect to the internet. Instead, they request the kernel of the host for the request, which is forwarded further to the using the host network, not using the Docker network. So host network just forwards the request when it's come to connection to the internet. And this process is also known as network address translation, NAT. I think most of you will be familiar with the concepts of NAT here. And the outside people will not be able to connect to the container. So what will happen basically? This will be a Docker. Let me just like clear the screen, and then let me just start again. And then it will be easier to understand. So what is actually going to happen? How our container is able to connect to the internet? This is the host system, and host system has some of the driver which is connecting to the outside world. This is connecting to the outside world. But what is actually happening? Now a connection is established between the host and the container. A connection is established here. So to connect to the internet, container will container will generate a request, and the request will be forwarded to the host. And host, by using its own network, not using the Docker's network, will just send the request outside, and then the request will be received by the host, and using the concept of the NAT, the request will be served back to the container. So using this, the container can access the internet, but anyone from the outside world cannot connect to the container, like because it does not has an IP which is dedicated to the server and which is not accessible publicly. Okay, so but if we so we have like seen how to just list all the networks. But other than these, like there were three, like host, bridge, and none. Other than these, like if we want to create some of our own network, so that we just want some of the containers to connect to each other, and we do not want any other container. Like there are 50 containers, and we want containers who can access each other, but none of the other container cannot access the container which is being specified in these five containers. So what we can do, we can just create our own network and add these five containers into the network that we have created specifically for them. So they will be able to access each of them, and none of the outside container will be able to connect to them. So how to do that? First of all, we will need to create a network, and we will just create our own Docker network, and then we will just run a container with the network. So how to do it? So let us see. So first of all, we need to create a network. So Docker network and create, and I will just create a network like test. So a Docker network is created, and when I list the Docker network, so there are four Docker networks as of now. Like this is a bridge, this is the host, this is the none, and this is the test. So a new network has just appeared. And if you want to start a container, like by default the container is started with the bridge network, but if you want to start a container with the other networks like host, none, or test, so what we will do, how will we start it? Like I will just run the command docker run hyphen it, and now comes the main option minus minus network, and network will be a test network, and I will just provide the image name. So like the now the network which will be used for this container will be the test network rather than the bridge network. So this is the way how we can achieve the concept of networking inside the Docker, and we can just run some of the container in a specific network. And suppose like we have created a network, and now then use of network is like finished, and we want to delete the network. So like as we can even see that like there are four networks and network, unless there are four networks that are like present, but at some point of time the usage of test network is not longer required. So we can just remove the network, and to remove the network, like docker network rm, and I will just write the network name. So the network will be deleted. But the three networks that are already present, like bridge, host, and none, suppose I am trying to like delete some of the network that is like I want to remove the none network. So none network is cannot be deleted. The bridge, the host, and none, these are the by default networks, so these cannot be deleted, and they are by default provided by the Docker. So this thing we can use to achieve the concept of networking in Docker. And continuing further, like to achieve the storage concept, like as we have already told you, like when the container is deleted, so everything inside it is automatically deleted, and the container is finished. But suppose we have stored something like I have stored some of the database. I don't want my database to be deleted every time I stop the container. I just want to preserve it. So what we can do, we can use the concept of Docker storage there, and using the concept of Docker storage, what will be happening is that the data that I want will be stored in my device, and it will not be lost. So how to achieve the concept of Docker storage? So what we will do, we will just when it comes to like storage concept, we will just tell our Docker engine that we want our data to be preserved, and we want this folder to be preserved. So the data in the folder will be preserved when we like let us have a look. Docker storage. First of all, like let me just create some of the containers, and what is going to happen, let us see there as well. Let me come back to the node one. So like I am just creating a docker run hyphen it CentOS, So I'm just running a CentOS image, and what I'm going to do, I'm just creating a directory mkdir and mkdir slash test storage, and I'm just creating a directory, and I am creating a file in the test storage directory vim slash test storage, and I'm creating a file like test, and okay, let me just use the vi command, and I'm just writing some of the temporary or random data in it. So I'm just writing some of the random data, and let me just save the file. And if I see like okay, 3 is not there. ls command, so test storage contains the test file in it, and when I like ls test storage directory is created. But as soon as I exit out of the container and I run a new container in it, I run a new container, what is going to happen? So like as soon as I see ls, the test storage directory is deleted. But I don't want my directories to be deleted. I want them to be non like persistent. And Docker containers by default have the nature of ephemeral, which last for a few time, and the storage is lost every time when we stop it and run it. We just want our data to be persistent. So we can achieve the concept of persistent data storage using the concept of Docker volumes. So how to achieve that? Like just let me exit from the container. So what I will do, I will first of all create a volume. What a volume is, a volume will store all the data that we want to store, and it will be stored in some location on our local device. So first of all, I need to create a volume, Docker volume create, and I will just type a volume name like test storage, test STO. And to list the available volumes on our Docker container, so we can do just like Docker volume ls. So test STO is available. A volume name test STO is created now. But how to like store the data, how to save the data which is persistent? So to do that, I will just like run a container docker run hyphen it, and to like I will just add a volume. Minus v stands for volume, and I will just type the volume name that I have created like test sto, and where I need to place it, I need to place it in slash test storage directory, and I will just type send to us. I want to run send to us. So now what is going to happen? Directory slash test storage is already present, and even if I edit some of the file in like what just happened? Let me just create another of the instance. Something just I'm just creating an instance, and I'm like coming back to the thing.
Guys, give me 2 minutes. New instance is created. Give me a minute.
Yeah.
Okay. Yes. Now you can use that.
Okay. Okay. So like what we are going to do, we will just like create a volume out of it, and after the volume is created, we will just do what we will just run the container with the specified volume that is present there. So let me just yeah, so it is now zoomed in. So I will just docker volume get, I will like test, I will just name it test, and like docker volume ls, and the test volume is created. So what I will do, like I will docker run hyphen it hyphen v test, and I am appending it to slash test str directory. And what I am going to do, I am just typing in a volume, like the CentOS image. So CentOS image is fetched up, and after fetching, okay, no space left on this. Why is it use completely? I'm just creating a volume test, and I will run docker run IP. What is happening with it? Let me just open some of the other labs. I think someone is playing with it. So I'm just up and creating a new instance out of it, as someone is accessing it and trying to compare it. So I'm just creating a new instance. Please be with us for a minute. Don't know why no space is left on the device.
still the problem is not resolved. Let me share my screen and we'll learn new things about Kubernetes and Docker Swarm. What is that and what we can do with that Kubernetes and Docker Swarm? Why we are using Kubernetes or Docker Swarm? Okay, just give me a second. I'm sharing my screen. So the presentation. Okay, so let's start with this. What is Kubernetes and what is Docker Swarm? We all know that they both are the container orchestration tool. What is orchestration? Okay, guys, when we are talking about containers, so we generally create one container, two container, or 10 container for a particular work. Okay, particular work. Now, what happened, guys? Sometime there will be the downtime or our container stop due to any network fault. Let's take an example. Suppose you have make a container where you make a container, okay, where you store your web page, okay, and this particular container can handle a load of 100 participants only, and there will be more than 1,000 participants on that on that particular container. So what will be done? Either this container will close down or this container will crash. Okay, there will be two things happen with this container. This container will be closed down immediately or crash. Okay, second thing is that when we are talking about containers, suppose I want that if this container crash down or close down, automatically a new container come up, okay, with a similar property what this particular container have. If this container is having the alpine image, so this container also come up with that particular property. Okay, so what we are going to do with to solve this problem, industry have two major container orchestration tool, okay, which is one is Docker Swarm, and another one is Kubernetes. Okay, another one is Kubernetes. So let's talk more about Docker Swarm or and Kubernetes. What they do when we host a container, and if we attach a container with any one of them, Docker Swarm or Kubernetes, okay, what they do, they automatically make the container replica if we needed. They automatically uh, they automatically up our container when they close down. Okay, and we can do a number of settings with our container, and we can modify our container according to us. Okay, let's talk about Docker Swarm in a brief. Okay, what Docker Swarm make a container which is known as Docker, which is known as Swarm Manager. We can say that. Who is Swarm Manager? Who manage all the other containers, all the replicas of a particular container. Okay, what this Docker Swarm do, guys? What this Docker Swarm Manager do? These all containers are slave containers, or we can say these all containers are slave container. This is a master node. Okay, this is Docker Swarm manage all these containers simultaneously. Okay, so this is something what Docker Swarm do for us. And uh, similarly, we have Kubernetes with us. Kubernetes is one of the is something which is the higher extent, which is something bigger than Docker Swarm, as it contain high it have many functionalities. Okay, other than Docker Swarm, it can automatically balance the load. It can Kubernetes, what can it do? It is an open source community. Okay, open source product which is from the Google. Now it is donated to CNCF. It is open source. Okay, it it is one of the biggest community in the world. Okay, then when we're talking about Kubernetes, so Google, IBM, okay, Google, IBM, and all the major companies are using these product to manage their workload. Kubernetes is one of the product which can handle, you know, a heavy traffic on their pods and softwares. While when you're talking about Docker Swarm is something which is compatible and which is productive in the smaller with our smaller projects. Okay, also Docker Swarm give you the functionality which it is compatible with Docker. First thing is this: it is easy to use and easy to manage when we're talking about Docker Swarm. Kubernetes is also compatible with almost all the major cloud. All the major cloud is compatible with Kubernetes. Okay, either we are talking about AWS, either we are talking about Azure. All the clouds have the Kubernetes service, inbuilt service with them. Okay, they have set of APIs which we can use for our services. Okay, there are few components of Kubernetes. Let's talk about that too. Okay, we have a very deep conversation on Kubernetes and Docker Swarm uh, on their respective meetups. But let me explain you very brief components. When we're talking about we have API server for Kubernetes, we have etcd for Kubernetes, we have schedulers. These all are the components of Kubernetes. We have kubectl, we have controller controller, and we have container runtime. Let's give me the gist of one by one. Okay, the API server is one of the major thing in this. This is act like the front end of this particular product, Kubernetes. Okay, this interact with almost all the containers, all the components of the containers. Okay, etcd, it's a key value store. Okay, it store the values that is used by our Kubernetes cluster. It store the key values of our Kubernetes cluster. Okay, then we are talking about scheduler. So uh, scheduler is something which is used to run our pod, run our different nodes. Okay, basically scheduler also distribute the response, the work with different containers. Okay, suppose we have a container and we want three more containers. So what scheduler does, it's distribute the work among these containers. Okay, so scheduler is having this as a major task. It distribute the work among the major containers with them. Then we have controller we treat as an mind, as a brain of the Kubernetes. This brain of the Kubernetes. And last but not the least, when we have kubectl is um, something like it's a command line utility. Okay, then what we can do with this kubectl, uh, we can control our pods, we can make new pods, we can build new pods. Pods is something like container. Pod is similar to container. Okay, we'll talk about that in Kubernetes meetup. So in a layman language, kubectl help to manage the pod, building the pods, and all the things which we are doing with the pods. So this is a little just about Kubernetes and Docker, but surely we have a meter for them individually, one for Kubernetes and one for Docker Swarm, and we're going to talk about that. So I think Kshitij, now is it
Yeah, like
feasible?
we can proceed further with the like Docker storage thing and that was left. So let us have a look at that. I have created a volume, and after creating the volume, what I will do, I was just running a container Docker run it Python b. I have created a test volume, and I'm mounting it to slash test directory on the CentOS container. So the container is run and I see that the test directory is already created. And if I modify anything inside the file, just like I'm just creating a test slash hello.txt file, vi is for I'm just inserting anything in it, just some random text, and I just and just I have just exited from it, and it's not full screen. So like I will just exit out of the container, and when I exit out of the container and I run the container again, I'm just running a new container. I'm just not running the old container, and I see like ls the test directory is present. And when I go into the test directory, the file hello.txt is also present inside the test directory. So using the concept of the storages, we can just like preserve and save the file, and if we require it anytime later, so the file will be accessible to us after some of the time. We can it is just like a pen drive, so the data in the pen drive will be stored even if the computer is format or if you attach it to a new computer. So you can consider it like some of the external storage device where the data is being stored, and the data is persistent even if you attach it to any of the like storage device. And even if we connect multiple containers to it simultaneously, the multiple containers can access the same storage simultaneously. So if we want to create a system where some of the live data is being updated by one of the container and it is being fetched by some of the another container, so we can just create some of the volume out of it and we can just run it. So this was the concept of Docker storage, and I think these are the topics that were to be taught during the Docker Dehradun meetup. Further, we will just conduct multiple meetup where you will get to know in-depth knowledge about the thing. And I think now we can exit. Now we can wind up with the thing. Karthik, you're on mute, I think.
Hello everyone. Thank you everyone to attend this wonderful meetup. Thank you for being so persistent with this. Okay, so we are very thankful to have you guys. And guys, let's meet again next month. Next month we have a deep dive meetup for especially for Docker. Then for Docker Swarm, for Kubernetes, we have meetup plan for all these things. Okay, if you want to join Docker community, so just you can just search on meetup.com Docker Dehradun. You can join us from there too, and you can contribute to Docker as well. Our trigger is uh, line up in the below. Okay, you can contribute to contribute.docker.com, where you can will find the all the task which we have what we have taught you. You also find that particular thing over the page, and you can also contribute to Docker. Okay, so that's all for our side. Thank you everyone. Thank you for joining us, and let's hope to meet you again very soon.